Still here? Can you hear me?
Yes.
I am not sure it was up. Okay, let's back to the second method. Okay, so I was saying when you will see two initial values is going to be given in the question. So the first one is the backward finite divide, which is x minus 1 and the initial x. So same like all the practicing methods also, we need to iterate till the percentage relative error is less than 0.05. And this is our true value. This is the value if you put it for this x and for this x, the function will be equal to 0. So let's see how we are going to solve this for second method. Okay. This is the function, and this is the first initial value backward finite divide, and this is xi. So this is the equation of to find a new value of xi plus 1. So this is what we need to find using the second method. Okay. So first iteration, I have the initial value of x, which is equal to the backward of xi minus 1, it's equal to 0. So from the equation here that I need to find the function of x and the function of x minus 1. So find the function of x minus 1. So x minus 1 is equal to 0. So when exponent negative 0 minus 0, so the answer is equal to 1. Now I need to find this portion or this term. So when x is equal to 1, so the function of 1 is exponent negative 1 minus 1. So putting the 1s in here. So the answer is equal to negative 0.63212. So now with these four values, I can now find a new value of xi plus 1 by filling up all this. So xi plus 1 is going to be equal to 1 minus the value of the function of x minus the step size 0 minus 1 and the function of backward fx minus 1 minus the function of x. So the answer is 0.6127. Okay, I can calculate the error. True value minus the result over the true value. So the answer is 8.0%. Remember, we need to iterate till the error is less than 0.05. Okay, so now we will go for the next iteration. So next iteration, how we are going to make the values. So we are going to move the data a little bit up. So we shift the data up. So this means xi minus 1 will not anymore is going to be equal to 0. It's going to be equal to 1. So this one will be here. And x will be taking this value. So second iteration, x minus 1 will be equal to 1. So this is why I said this value will be moved up. And x will take this value. So it's 0.6127. Again, we need to find the function when x is equal to 1 and the function when x is equal to 0.6. So the function when x is equal to 1 is equal to negative 0.63. And the function when x is equal to 0.61, so the answer is equal to negative 0.0708. So with these four values, I can put them inside this equation of second methods to find a new value of xi plus 1. So you can see from here is the answer is 0.563. Look at this value, 0.563, and look at the true value, almost equal to the same. So now let's calculate the error. True value minus the result over the true value. So the error is 0.58%. Still, we need to achieve the error it's less than 0.05%. So this means I need to iterate one more time. So for the next iteration, x minus 1 will be taking this value. So it's coming here. So this one no more is equal to 1. And x will take this value. So let's see it. X is equal to 0.61. That means it's taking this value up. And x is equal to 0.563, this value. And again, you need to find the function for this value and the function for this value. So it's negative 0.07. And here it's 0.005. I have these four values. Use them inside the second methods to find a new value of xi. So now when you are going to calculate the new value of xi, you will get that 0.5671. It's exactly equal to the true value. So when you're going to calculate the true value, it's 0.0048%. So you need to stop. So this value is considered is the root. This is for the second methods. If you want to try it, I will give you about 5 minutes to try. If you have any questions, please do ask.
Sir,
Yes.
so basically, for the difference of Newton-Raphson method and second method is Newton-Raphson method. The question will give x zero, x initial, x zero, and want to find
Uh-huh.
the final x one plus one, right?
Yes.
Okay, so for second method is the question will give uh, final x
Two
one
initial values.
to find
Yes.
the initial back. Oh, so is the reverse of the second method is the reverse method of the
No,
Newton, like that.
no. All of them is the same. All of them, they are
Oh,
trying to predict what's the value at the coming point. So all of them, they are trying to find xi plus 1. All the methods,
okay.
even the practical methods, most of the time you are trying to find xi plus 1. You are trying to predict what's the coming value forward. Okay. The only difference between the Newton-Raphson and for the second methods is Newton-Raphson, it's used the first derivative to find xi plus 1. Second methods is just only to make things simple. They are not using any derivatives. So instead of the derivatives, they are approximating the value of xi minus 1. That's why you are going to have two initial values to find a new value of xi plus 1.
Okay, thank you, sir.
Okay. Okay, so let's move to the last part of today. So this is not a new method actually. This is just only a second method. It's second method, but it's modified to make it more efficient. So this is an alternative way of for the second methods. What we are doing in here, instead of we are going to use the backward finite divide. So this means instead of we are going to have xi minus 1 as an initial value, we are just only using a small perturbation fraction number or the constant value. This will help us to solve to find a new value of xi plus 1. So this constant number or the small constant number is going to be given, for example, it's to be maybe 0.01 or 0.03. This constant number is going to be given in the question. So with this help of constant number, we will create 2 points. So the first point you can create is this constant number times x, and another one is x plus the constant number times x. So we are going to have also 2 points, then we are going to find a new value of x. Maybe it's not clear now, but when you are going to do the same example, the picture will be clear. So let's see it how. So here we are going to say that use the modified second method to estimate the root of this function. Use the value of 0.01 as the perturbation fraction number or the constant number. So this is the constant number we are going to use, 0.01. But see what's the difference here. The starting initial value of xi is equal to 1. Here, modified second methods, it will not give you 2 points. It will just give you initial value, one single initial value. So we need to iterate till the relative error less than 0.01. And this is the true value. So let's see how to solve. So this is the function and this is the initial value. So remember here, modified second methods will just give you one initial value and will give you a constant number. So this is the constant number. Okay, so this is the equation. We need to find all these parameters. So you need to get this point and find the function for x and the function for x plus the constant number times x. So this means the first thing, this is my initial value. So the function for the initial values, which is the function of x here, it's equal to the function of 1. So I put 1 here and 1 here. So the answer is equal to negative 0.63. The next value I need to find x plus the constant number times x. So x is equal to 1. So 1 plus the constant number 0.01 times x, which is 1. So the answer is 1.01. This is my second point, which is now this value. I need to find the function for it here. So what's the function when x is equal to 1? So I put here 1.01 and 1.01. So the function when x is equal to 1.01, so the answer is negative 0.64. So now I have all the four values. Then I can put them here inside this one to find xi plus 1. So xi plus 1 is equal to initial value of x, 1, minus the constant number times x, which is 0.01 times 1, minus the function of x, which is negative 0.63, over the function of 1.01, so it's negative 0.64, minus the function of x, which is negative 0.63. So the answer is 0.5373. You calculate the relative error, true value minus the result over the true value. So the error is 5.3%. So still early to reach 0.01 as an error. So we need to iterate one more time. But this time when you are going to start, x will no more equal to 1, x will be equal to 0.537. So we start with the second iteration. X will be equal to 0.5373. X is equal to 0.5373. It's taken from this value here. So I need to find the function of x is equal to 0.53, so I will put this value inside my function here. So the answer is 0.047. So now again, I need to find this point, x plus the constant number times x plus the constant number times x, which is x is 0.537 plus 0.01, the constant number, times 0.537. So the answer is 0.54. So now I need to find the function for this value. So the answer is 0.038. So I have now these four values. I will put it again inside these equations to find a new value of xi plus 1. So xi plus 1, you can look from here, it's 0.5671. If you look at this value and the true value, they are almost equal to each other. So it's 0.02%. Okay. So the third iterations, then you are going to find that the correct answer is coming in here. So this is how to use the modified second methods. Okay, that's the difference between them. So now you already know about bracketing methods and open methods. What's the advantage of using the bracketing methods? We are saying that it's the good things about using the bracketing methods, that it's all the time bracketing methods, they are converge. Why? Because the root actually it's between the two initial values. The disadvantage of open methods that it's sometimes converge, sometimes is diverge. But the advantage of the open methods is they are more faster than and more efficient to estimate the roots better than the bracketing methods. So no need for you to iterate a lot of times to find the same answer. Okay, so that's the difference between bracketing methods and open methods. Okay, so now there is another things maybe some of you notice. If we are looking at the equation of second method, this equation in here, and somehow it's exactly like false position methods. The methods, they are using the same exact equations, linear interpolations. But what's the difference between false position methods and what's the difference between the second methods? They are both of them similar because false position, it's using two initial values, which is x lower and x upper. Second method, they are using x and x minus 1, or x and backward Finite divide. So the similarities is both of them, they are using two initial values, and both of them, they are using the same equations to approximate a slope function that is used to project to x-axis, which is what we call it last time, the linear interpolations. So this is the similarities. Two initial values, same equations to find a new value of x. But what's the difference? How one of the initial values replaced by the new estimates? How we are exchanging, or how we are trying to find the value of xr, how to find the roots. So graphically, if we start first position methods and the second methods, at the first iterations, both of them, they are exactly the same. But for the second iterations, you can see there is false position methods, it's going to be converge to find the value of xr. But for the second methods, maybe it could be shoot behind and it's diverged. So you are not going to find the exact root. So this is the difference between them. Okay. This is an exercise. I can, now it's about 9:40. I'll give you about 15 minutes. Okay, 15 minutes to try to solve this exercise. Then you can compare your answer with my Excel file. what you need to do in here, first, you are going to use the fixed point iteration methods. Just only you are going to make 3 iterations. You cannot make it all. Just make 3 iterations only using fixed point methods and try to develop converge on the root. And also Newton-Raphson methods, just only 3 iterations to find the answer. And also second methods, 3 iterations with the initial value of x minus 3 and x is equal to 4. Let me show you here is the true value actually for this example is equal to this value. This is the true value here. So you can calculate the error. Remember, just only 3 iterations for every method here. 3 iterations using fixed point, 3 iterations using Newton-Raphson, and 3 iterations using the second methods. And this is your true value to calculate the error. Okay, I will give you about to the end of our class today.
Sir,
Yes.
can sir show the calculation of example modified second method?
Sure.
All right.
By the way, all these examples you can find on the textbook.
Thank you, sir.
Okay, welcome. Okay, so try to make this A, B, and C. After 15 minutes, I'm going to show you the answer so you can compare your answer with my Excel file. Okay, so while you are doing that one, so let me make my coffee because I am late for it. So I'll give you 15 minutes. Okay, just to compare your answer with my Excel file here. You are saying that you're going to have about 3 iterations, right? So this is the answer for the fixed point. And this is for the Newton-Raphson. The answer for the second method. There's another exercise in here if you want to try it by yourself, and you can check your answer with me afterwards, or you can text me later. Sure, you can do that. So since now it's almost about 10 o'clock, we are came to the end of our class today. So please, could you write here it's your name, your student ID, and again here, please write your group, because I have today is 2 groups, C and E. So I want to easy for me to write your what is your group instead of I'm looking for between 2 files. Thank you very much. If you have any questions, please do ask. If not, so I will see you inshallah for the lab. I'm going to teach you how to use the MATLAB and Microsoft Excel to find the roots of the equations. Still week 4 is coming. Still we are going to talk about the roots of the equation, but the important things here, we are not taking any new methods. We are going to talk about multiple roots. So how to use Newton-Raphson's or the methods that we had learned, how to use it to find the multiple roots. And after that, we already finished the chapter of how to find the roots of the equations. So concentrate on the methods of bracketing methods and open methods. Next week, you are not going to be exposed to any new methods. We will just only going to continue using our methods for Newton-Raphson fixed point, and we show how this one is going to be help us to find the multiple roots of the equations.